Hey everyone, and welcome back. Using the periodic table, determine the position of each pair of specified atoms. Number 1, determine the total number of valence electrons for each element. And number 2, provide the total number of core electrons for each element. We are going to begin solving our problem by adding a simple periodic table which will allow us to answer each of these questions. Starting with 1. Problem number 1 says that we want to determine the total number of valence electrons for each element. And for A, we have sodium and potassium. So first of all, let's add sodium and potassium. And let's identify their position. So that's sodium in group 1A, period 3, and potassium is in group 1A, period 4, right? Our period corresponds to the row number. So that's 1, 2, 3, and 4. And that's our group 1A. So because sodium and potassium are in group 1A, they must have one valence electron. Okay? So basically, if you remember, whenever you're dealing with a group A number element, it will have the same number of valence electrons as the group number it is in. And as you recall, the number of valence electrons corresponds to the number of outer shell electrons. So we have one valence electrons for sodium and potassium because they both belong to group 1A. Now we are going to look at 1B, and we are going to determine the number of valence electrons of boron and aluminum. Let's find them. Here's boron in group 3A, and here's aluminum in group 3A. So basically, because they belong to group 3A, they must have 3 valence electrons each. Moving on to problem number 2. We want to provide the total number of core electrons for each element. Remember that the number of core electrons is equal to the total number of electrons minus the number of valence electrons. This is reasonable, right? The core electrons are all of the electrons that an element has except from those in the outer shell or the valence shell. So we have to find that difference. If we look at A, and if we think about sodium first, to find the total number of electrons that sodium has, we simply want to look at its atomic number. Sodium has an atomic number of 11. So an atomic number corresponds to the number of protons and the number of electrons in that atom. So we're going to say 11 minus 1 valence electron because it's in group 1A. That gives us 10 core electrons. Now for potassium, its atomic number is 19, and if we subtract 1 valence electron, that gives us 18 core electrons. Now if we think about part B, boron, its atomic number is 5, and we have to subtract the number of valence electrons, that's 3, so we get a total of 2 core electrons. And finally, for aluminum, its atomic number is 13. We have to subtract 3 valence electrons because it's in group 3A, and we get 10 core electrons. Let's label our answers. So once again, potassium and sodium, they both have 1 valence electron. Boron and aluminum, they have 3 valence electrons each. The number of core electrons for sodium is 10. For potassium, that's 18. For boron, that's 2. And for aluminum, that's 10 as well. Based on these answers, we may conclude that the correct choice to the multiple choice question is D. Thank you for watching.